All right, good morning and happy Sunday. I'm planning on doing LeetCode contest, the bi-weekly contest 82 from yesterday. So let me share my screen. We'll get going here. Okay. Hold on. Okay, so here we go. Bi-weekly contest 82. Time to shine. Clock is ticking and we are keeping score. Let's open these guys up and start jamming. Okay. 2% Boolean or 3 is Boolean and. False and true. No, that's okay. Okay, so this is a post-order traversal, and then as the recursive stack unwinds, we and or things from the left and right children. By default, a node that doesn't exist will be true or will it be false? Simple one. What if we don't have it? Oh, it's a full binary tree. Okay, so that never occurs. Okay, cool. Okay, so 6:34 a.m. for implementation. Python 3. Go. Node equals root. Go. If not node.left and node.right, then this return node.value equals 1. It's true or false. Okay. Otherwise, L equals code. Oops. Go node.left. R equals go node right. The node value is 2, it's or, it's 3, it's and. L or R if node.value equals 2, else L and R. Okay. So expect true and false, so that's good. Okay, cool. 6:43, 6:34, 6:36, about 2 minutes, right? Is cool. And then we can probably shrink this up even, right? If we want to. I'm not sure if we want to or not, but whatever. Nah, that's good enough, whatever. All right, we don't need to make it any fancier. Let's just move on. It doesn't have to be perfect. Okay, so a few solutions. On 3. Recursively recursive post order traversal of that tree. All right, that's cool. Yeah, that's good. Kotlin, JavaScript, C++. Let's do these real quick and then move on. Go capture yourself in there on Lambda. Boolean, which takes in a tree node cleaner. Node Okay, so if it is a leaf node, then we'll return node value 1. Otherwise, we'll go L equals go nodes left. Let's go node right. And then return nodes value equals 2, then L or otherwise L and okay, something like that. True and false. That's cool. Yeah. Okay, JavaScript. Root, go. Node is equal to root. Go. If not root dot left and not root dot right, it's a leaf node. Our node I is equal to 1. Otherwise, let L equal to go node dot left. R equal to go node dot right. And return node dot I equals 2 L or R. Otherwise, L and R. Okay. Uh-oh. Oops. It's node, not root. Okay, that's good. Okay, let's do this in Kotlin and move on. All right, so if node left equals null and node right is equal to null, and we'll return node value is equal to 1. Otherwise, L equals go node left, R equals go node right. If node value is equal to 2, L or R, else L and R. Okay. Looks good. It's cool. Okay, good enough. Okay, and we have hour 22 minutes left. 1 hour 22 minutes remaining. Test. Okay. Given zero-base index integer, bus departure passengers, the arrival time of J passenger. Very unique. Okay. Not necessarily sorted. Capacities 2. First bus departs with the first passenger. Second passenger. 16. Return the latest time you may arrive to catch a bus. There's two buses. They leave at 10 and 20. A sort and binary search needs to be a near-linear algorithm. Right. Since n equals 1e9, n equals 5 equals 100,000. All right, we are looking for a near linear algorithm from time. Preprocessing input, yes, sort, it's binary search. We want lower bound or upper bound, something like that. $644. Come with the game plan here. Okay. 20. This equals 10, 20, 30. Passenger equals, let's sort this, so 4, 11, 13, 19, 20, 21, 26. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Which one am I missing? 25. Passengers. I equals 0, 1, 2. J equals 0, 1, 2, 3, 4, 5, 6, 7. Third bus departs with you. Okay, so you want to catch a bus. The latest time. Latest time. Why is it 16 though? Why isn't it 20? Oh, these guys are already in the queue for 20. These guys are already there first. Okay, so that makes sense. Okay, so latest time. So we try 20 zone option because, well, why not 20? Why can't we arrive at 20? I don't get it. Okay, because 17. Okay, so 2 gets on 10. 17 and 18 will get on 20. We should be able to do a linear scan then, right? So this guy would be here. We go into that guy. So this guy y is less than or equal to x. Let's let these guys be y, these guys be x. Y is less than or equal to x, then you can go there up to 2. Let's process it like a sorted queue. Okay, so person 4, passenger 4 gets on the bus that leaves at 10. Capacity 2. Just say K is our capacity. Capacity K equals 2. Okay, so that bus left with this guy. Now who gets on the 20 bus? Right, so passengers arriving at 11 and 13 get on the bus that leaves at 20. Right, so this guy and that guy get there. And passengers 19, 21 get on the bus that leaves at 30, and that's it. All right. You guys are out of luck. You don't get no bus. Okay, so the latest time would be the last bus. So if there's an empty slot, and then we can process the bus in reverse order. 20 is between 19 and 21. For binary search. Latest time we catch up bus. We'll go through the example 1 here real quick. Ten 20 equals 0, 1. Passengers. These guys. 2, 17, 18, 19. J equals 0, 1, 2, 3, 4, 5. Okay, so passenger 2 gets on bus that leaves at 10. Passengers 17, 18. Get on the bus that leaves at 20. This one's tricky. So yeah, I'm not going to solve this one. Right. I can do the simulation. We can know who gets on what bus based on the capacity. Then how do I go back through this and find out, okay, this one's 16. You have to get on these buses. Earlier arrival time goes first. What's it? Linear scan from 185 downwards. Available value. You just keep it super simple. Right, we start from 18. I think that works. Okay, so let's see. This is our bus, this is our passengers, and this is our capacity. MN equals length of our buses and length of our passengers. IJ 0, or traverse those. Okay, so while I is less than M and J is less than N. Array of folks that we have. And we'll go through that array. I is the last value in the array. Seen to be a set. So while I and seen, I minus equals 1. Let's I at the end. So I is less than M, J is less than N. many people are on the current bus? What we have on the ith bus is 0. So all I have is less than k, which is our capacity. And j is less than n. And we'll add them on there. Let's see, and a sub I, right, b sub j is less than or equal to a sub I. Right, so that's the x value. Each y is less than x. F is encoded by 1. J is encoded by 1. And oops, this is not A, it's people, right? So the bus leaves at the ith time and the jth person. Right, that's right. Jth passenger on the ith bus. A dot append the jth passenger. So we have. Okay, then I bus is then full. Okay, so those are our passengers, and we'll go through the passengers and scene. Scene equals set of A. Okay, something like that. Okay, that's 16, and then 20 for the other one. Uh-oh, 3. 3 is not right. Something's not right here. Okay. So let's print this. Print A. See what we got here. Scene. 2, 17, 18. Or gets on the first bus. It should be 11 and 13 get on the second bus. So hold on, I didn't sort it. Okay, hold on. B dot sort, P dot sort. 16 and 20, that looks good. Oh. Okay, I kind of mixed up the game plan and implementation. Implementation altogether 702. So 16, 18 minutes, which results in the wrong answer. Oops, hold on. Let's do this. Let's comment this out, stick this here, and then fix it. You can learn a lot from failure, hopefully, with the open mind. Here we go. So puts 3 for the bus, right? Bus, oops. Bus equals 3. Passengers is 2 and 4. Capacity is 2. Oops, printing scene. 2 gets on that bus. Oh, you have to get on a bus there. So 3 is, wait. Did I output 2? What? Capacity is 2. Spec 3. When does the bus leave though? It's not quite that naive. They process the buses in reverse to get on the last bus. All right, maybe process buses in reverse. Okay, so go to the next bus. Wait, hold on. That goes in -1. There's a bus. Lower bound of A for the value bus leaves at for the last bus. Well, I is bigger than that. High minus equals 1. High not in scene. Turn high. I minus equals 1. Okay, so then if we don't get on any buses until the very first one, the first bus yeah, all those are full. Okay, something like that maybe. Lower bound. Oh, it's I sec left. Oh, that's not right. 16 and 20. Oh, this one I might just skip. Holy cow, I'm making this one pretty complicated. 3, so that's not quite right. Should have been 10 anyhow. Set our passengers. Already have passengers, so 2, 17, 18 is what it should be. All right, 2, 17, 18. Then 16 would be the next one. Right, which would push the other ones out. $16 is what I want. For 11, 13, 19, 21. So 20 is that first gap. So it's the first gap in the middle or last passenger, like it's on there, -1 for the last bus. 20. Two, 4. We said 3. So 3 get on there. So we always want to go on that last bus if we can. Get on that last bus if we can. Hold on. Maybe I was closer than I thought. Hold on. Let's go back here. Last bus. That should be good. Wait, 20 and 30. No, it doesn't work because you have to be in this queue before that cutoff. In the queue before the cutoff. Remember to KSS, keep it super simple. It's time to catch the bus. That one's throwing me off. Oh, this is real tricky. Okay, so let's do 50 minutes left on Q3. Skipping past Q2 to move on to Q3. At, was it 53 minutes left? Painting contest, 53 minutes. There's 40, so 50. 49 minutes. Okay, whatever. Let's move forward. Should have grabbed some coffee. Okay, yeah, that's kind of a bummer. I didn't figure out Q2, but we'll fail forward and look at that again with a fresh set of eyes and just throwing stuff up on the wall, seeing what sticks. It's always a good time to move on. Let my subconscious hopefully work on it. I'll solve it later. So anyhow, let's move forward. Given two positive zero index arrays, then sum of square difference. That minus that squared. You can modify any of the elements, +1 or -1 at most. Okay, 1 times, okay. Return the minimum sum of square difference. So I want to get them as close to each other as possible. After modifying this one, that many times, you are allowed to modify the array to become negative integers. Okay, that's fine. They're both 0. Okay. K1. Okay, so we want to greedily close the gap, right? So we can use minimum priority queue. Game plan is to use a minimum priority queue. Heap for a greedy algorithm, which cherry picks the largest difference. To be reduced. Does that sound right? Just difference to be reduced. Because when you square it, so it makes sense to pre-process the input and sort them, right? And then increase that once, increase that once. Okay, let's see if this game plan actually works out. Okay. Well, we can't do anything here. above, but this one we can. A equals 1, 4, 10, 12. B equals 5, 8, 6, and 9. Okay, so the difference is 4, 4, 4, 3. So we can change those to 3, 3, 4, 3. So the square would be 9, 9, 16, 9, 27, 16 is 33, 43. All right, 27 plus 16 is 43. Okay, that makes sense. All right, let's do this. A, B, I'll just do X and Y, whatever. Doesn't matter. Okay, so then let's do A dot sort, B dot sort, and then N equals the length of A. Diff equals, let's do this. What's the difference between A sub I, B sub I, for I in range length A? This will be our Q, which we can heapify. Hold on, heapify the Q in place. So that's what Q, absolute difference is. So we want the maximum of it. Maximum would be negative minimum. And then we can reduce wait to take, hold on. Does that sound right? Always take the biggest and reduce it by 1. Take the biggest delta and reduce it by 1. These are the things that we have. We'll have, we can reduce it, right? I equals Q dot heap pop Q. Plus 1. N equals 1. Heap push I back on there. Turn. sum of x squared or x in q. 577. Oh, that's not right. Should be 579. Uh-oh. The Q. 16, 16, 1, and 8. What? 1, 8, so 17 and 15. What? How is this possible? What the heck? How's it 16? What? So I must be small. How is this not 17? What the hell? How is this not 15? This is 1, that's 8. What? Need some more coffee, I guess. Holy cow. The heck? How? Oh, wait, that is. Oh, it is 16. Oh, okay. Oops. Yeah, that is. Wait a sec. 19. Okay, so 20 and 19 are. Okay, so I'm not able to sort them then, right? Is that right? Yeah, I can't sort them. Okay. Sorting is not allowed. Okay. That makes sense then. All right, that's easier. Okay, 43 for the other one. Holy cow. Oops, I looked at that wrong. Okay. Uh-oh. Heap push expected 2 arguments got 1. Okay, heap push onto the queue. 43. Okay, so confused myself a little bit. That's cool. Okay. It's taken a while. Go, LeetCode, go. Uh-oh. Output is 8, but expects 0. Well, something's not right. All right, so what's going on here? So delta is 9, 10, 4, 5, 4. So we have 38. It's 38. That's 8. We expect 0. 19, 23. 28, 32. Huh. Oh. Oh, okay. So if not high, just break. Right? We don't want to keep going in that case. I is incremented. So in that case, we went too far in the other direction, right? Okay. Big money, no whammies. Oh, TLE, okay. We're getting somewhere. Eek. Okay. Million, 3 million operations? What? Billion. Okay, so this results in TLE. It'd be nice to get partial credit for TLE. TLE is pretty close, right? Fairly close. Partial credit. Okay, so instead of distributing them in piecemeal fashion, one at a time. Yeah, so question here is how to improve speed. Right, so instead of piecemeal fashion updates. So purchase difference. One updates faster. I think so. I think we can do the updates faster if we want to. And take the whole chunk until its difference is exceeded by the next biggest chunk. Man, this is tricky too. LeetCode's kind of like challenging problems for sure. I got 30 minutes left. Dang. This one's tricky. That one's kind of tricky too. Subarray with elements greater than varying threshold. I suppose we can look at the fourth one. All right, whatever. About 29 minutes left in the contest. Remaining in the contest. Okay. Find a subarray of nums of length k such that every element in the subarray is greater than threshold divided by k at the average. The only valid subarray is 343. Can return any of those. This is a subarray of size 1 not okay here, though. Oh, okay, the bag has to be greater than the threshold. If any x in a exceeds threshold t, then return naive. Right, that one's super, I guess, naive use case. Otherwise, if there's all values x are less than the threshold, you have to combine two values or more. All right, we're looking for a two sum. .5. Man. Definitely not one of my best contests, that's for sure. I have a lot of room for improvement. Yeah, this one is, some of these are tricky. Mm-hmm. I'm not sure how I'd even want to approach this one. Do prefix sums and a sliding window, maybe? Prefix sum, a sliding window. Let's see, if A equals 1, 3, 4, 3, 1, 0, 1, 2, 3, 4, 5. This equals 0, 1, 4, 8, 11, 12. And a J non-inclusive. So the window, total within the window is 0. Total, and the threshold is 6. Six, total 0. So we need to keep track of the minimum value in the array as well, right? So, okay. Size of it. Divide the size of it, right? So can't divide by 0. So t will equal 1. Minimum is 1, which is less than 6 divided by 1. So that's no good. How do you expand it there? How do you expand the window? Hmm. Wow. This one is tricky too. Okay. Well, today morning is just not my morning. Or these are just hard ones. This one is only 4 points, so I think it'd be a little more straightforward to catch these buses. Hmm. these passengers on the bus. I still did wrong on this one, huh? Okay, so 3 is fine on that one, but then 30 is wrong for the other one. It should be 20, then, or no, it should be 16, right? 16, 20, and then 3 for the other one. Two people on that bus, so I can't just take 30. These ones I'm just going to have to go slow with and just figure them out, pen and paper. These are not working, just typing them in and trying to hack on them. Sometimes they're just best upsolved with pen and paper, so I'm just going to call that. We'll do, I suppose, not much to see here, I suppose, either. Could be an easier way of doing this, right? So these are passengers that get on these buses, and then stick yourself in there. Stick ourselves in there after we decided which passengers go where. These are the passengers that go where. It's not last in time. Many folks are in the queues. It's a full bus. All right, so process this from left to right, then process that from right to left. And process it from right to left. Like, how many people are in this bus? That are not in the previous bus. Right, if the bus is not full, then it's the last ending time of the bus. Bus is not full. It's the last ending time of the bus. Hold on. That's not right at all. I thought I was close. Maybe this is the closest solution I got. 1620, but then 1 is not right for this one. So as long as the bus is not full, oh, append and equals K. Bus equals bisect left. I. If not full bus, then can return a sub index of I. Ith bus is not full. B sub I. Oh, not full sub full. Okay. Ah, nope. Expected 1. Two. But 2 is expect 1. And B sub I not in scene. Oh. 3. 3, 4, and 1. Oh, expected answer is not shown during the contest. Okay. Really? The bus leaves at 3. Their passenger shows up at 4. That bus is not full, right? It's empty. So then just the last bus. It's empty, this last bus. If not, length of A, turn B sub into 1. Last bus will be a corner case. So 3 seems reasonable to me. Oh, 16, expect 18. One person per bus. That one's not full. The full. So the last one should not be full, and that's the one we should take, right? That one's not full. So that's the one we should take. I equals the maximum of a sub last one. Okay. It's 18 looks good. Okay. Oops. Okay, that looks good. Oof. Up is 20. Oh, crap. Okay. Let's fix. Oh, okay, so those are wrong. Yeah, so I'm just throwing stuff up on the wall, see what sticks, and it's not really that great of a strategy. I'm just getting that far very fast. And you need to regroup and come up with a better plan. I'm going to keep it super simple. It doesn't work. You said -1. If it's not full, then we can take it, right? Not b set -1, right? So it's not full. Last bus is not full. Maximum, let's b set -1. So good. I don't know. Oh, okay, cool. Yay. Clutch move. Got that one done with 5 minutes left. Okay, cool. Yay. This one was finally AC. With now 5 minutes remaining in the contest. Failing forward one test case at a time. Yeah, I mean, it works. That's cool. I got 2 instead of just 1. Man, that's tricky. A lot of corner cases, like, what? So definitely have a lot of cleanup, a lot of room for improvement. Let's see, we got 4 minutes left, so I don't know if I can do this on 4 minutes. T-lead. This one, I don't even have an idea how to even start this one yet. Well, okay, yeah, that's a naive case, but then How to get a near linear algorithm to figure this out? Sliding window prefix sums is what I was thinking, but how do you know when to shrink and expand the window? It improves, you expand it. Or does it make it worse? You shrink it. Maybe. Yeah. This is one of those contests is a good humbling experience. 3 minutes left. Right. When to shrink, expand window. If it gets better, worse, right? Okay, well, that's cool. I got 2. Almost got this one, some TL8. I think this should be partial credit. I mean, decent solution. How do you increment, right? Piecemeal updates. Pop the top 2. Okay, so yeah, 1 minute left, 90 seconds or whatever. Wow. It's only one of these things. Max equals take. It's not right. Okay, contest in it anyhow. Time to upsell those later.